aspect than Bethesda is primarily research. Philadelphia has more in-service engineering than research. We're about 10% of the organization in Philadelphia is R&D, and the remainder of the organization is in service. So I pretty much talked through. Is it going? Okay. So I pretty much talked through the entire spectrum. So we see the S&T, we do the R&D, the concept development, we develop prototypes, and we put them on ships. And once they're on ships, we help maintain them, upgrade them, and then when it's time to dispose of them, we figure out how to do that as well. Also in Philadelphia, and I mentioned the organization briefly, at the beginning of the spectrum is one of the divisions, and it happens to be the division that I work in, which is the Machinery Research and Development Group. So we work in the front end of the life cycle. So we're working in the concept development. Once we develop a prototype, it crosses over and the in-service folks take it over. So in Philadelphia, we follow that life cycle. And the group that I'm in, we have all the R&D across all the different types of equipment. And then the remainder of the groups are broken up into divisions. So you have steam and auxiliary systems, propulsion and power, and all the other portions of the ship. I think Tom talked about this a little bit, and our mission is we take care of the maritime machinery. So all the machinery on board ships and submarines, we take care of in Philadelphia. And I already told you it's full spectrum. And about roughly half of the organization of about 3,300, roughly half is in Philadelphia and the other half is in West Bethesda. I kind of went through this real quick. You can read the screen, but just the sheer number of bullets on that slide tells you kind of the breadth of equipment that we're responsible for in Philadelphia. So the machinery covers, as I said, pretty much everything on the guts of the ship. So you have from life support to generators, all the diesel engines, gears, gas turbines, pumps, compressors, air conditioning systems, you name it, it's pretty much there. And if I'm going too fast, I'm just kind of trying to get the information out for what's happening in Philadelphia so that we can get to the good stuff. In Philadelphia, we have also some labs, test facilities. So we have a full-scale engineering site. It's basically half of, not basically, it is half of a DDG 51, a destroyer's power plant. So we have the gas turbine, the shaft. We don't have the propeller, but we have the water brake that simulates the propeller. So, and all the control systems. And actually, sailors come there and train on that system. The other thing it allows us to do is test any new equipment and new control systems, any other pieces that we want to, test. So it's a kind of a unique facility. I guess, again, Tom mentioned some of the things that we do as an organization, but some of the things in Philadelphia, the systems integration, and that kind of means, how do you get it on the ship? What's going to happen when you put all the different components together? We're responsible for all those system effects. Installation of ICAS in Philadelphia developed a condition assessment system. So it's a monitoring system, monitors all the different shipboard systems. Test and evaluation, electric ship technologies are a big driver right now, something that's pretty interesting. So they're trying to make an all-electric ship. EMALs, so it's electromagnetic launch, we do those types of things. I'll kind of skip through some of these things. Again, just some pictures of the thing. So I guess before I go into this, and there's not too many more slides because I'm not going to make everybody go to sleep, hopefully not, is I just wanted to tell you, I'm going to tell you what my branch is doing. I'm a branch manager in Philadelphia. About 17 people work for me, and I do the machinery systems integration piece. I'm just going to go through one of the projects, one of the things that we do. But before I do that, I mean, I guess one of the things that you're interested in, and what I was told while you're here is, you know, how did I get to this point in my life, in my career? So I'll go through that real quick, as quick as I can. I went to school here at Penn State, in mechanical engineering, and what happened was I had no, my goal was get a job. I didn't say I'm going to go work for the Navy and I'm going to do machinery systems integration. I didn't know what I was going to do. My goal was get a job. Actually ended up, one of my roommates graduated ahead of me, went and got a job down here in DC, or not here, but in DC for a defense contractor. So when I was getting ready to graduate, he said, "Hey, give me your resume, I'll give it to my boss." So I ended up working, that's how I got a job with a defense contractor. And what I ended up doing was, I worked on machinery systems that were being developed, but I didn't really work on the systems. What I did was develop the test and evaluation, the master plans, and do some of the calculations for failures. So, and that's kind of how I got started working with the Navy in machinery. And it just kind of blossomed from there. I really liked it because, you know, like Tom, but unlike Tom, I didn't travel the world, but I got to go from Washington, D.C. to the laboratory in Annapolis, which is now closed. So I got to go to the research lab where they were developing all this machinery and see, you know, what they were doing and actually work with some of the engineers down there. So then I go back and forth, do the test and evaluation master plans. So I worked for a contractor. Eventually, I ended up going over to the headquarters Navy, which at that time had a research department. It was an office in the headquarters that kind of was in charge of overseeing all the research that was being done. So and then I went to work in kind of the management office that oversee and was responsible for basically convincing the Pentagon to give them money because this is the kind of research that the Navy needed to do. So I was kind of in the middle, but now I was in management or sort of program or project management. I was helping to do that. And I liked that too. But I was still in the, you know, still in the machinery, still on the research side, but it was a little more management. I ended up going from NAVC to Philadelphia, which was more of the technical integration piece, where actually I worked on the early design pieces of one of the things that I mentioned, the integrated condition assessment system. So I worked on program, the predecessor, which was EDMS, which was a data management system, which doesn't really matter to you, but anyway, so I worked on that in Philadelphia. I ended up taking the data from that, and I ended up going back and doing the failure calculations like I was doing when I first started, but now we had a tool to give us more information. So, you know, there was kind of a common thread that was starting to be, you know, woven through everything I was doing. And eventually I moved into a management position in the maintenance, the fleet maintenance group. And so I was able to use, you know, my knowledge of the failure rates and try to integrate ICAS data into the maintenance systems so that people the sailors could do a better job maintaining the equipment on the ships. So eventually, you know, that's how there was a common theme, right? And so I was on the in-service side helping to maintain the ships, developing these maintenance systems. And then an opportunity came to work with the R&D group because the Annapolis office had closed. It was being closed, and the machinery research portion of that was being moved to Philadelphia. So the group that I worked with in Annapolis was now coming to Philadelphia. So when it arrived in Philadelphia, I actually went over to that group, and I worked in machinery R&D, and that's where I am now, machinery systems R&D. So I actually made kind of a giant circle. So I don't know if that helps anybody, but I didn't know exactly what I wanted to do. My main goal was get a job, but I like the machinery aspects. I like trying to figure out what makes them tick and what makes them fail. And then what I also found out was I actually liked working with people and managing a group to come to an end goal. You can't always get to the end by yourself, so you have to bring other people with you. And I found out that I liked that, so I ended up in management, and that's kind of where I am now. So I don't know if that's helpful or what you wanted to hear tonight, but that's sort of the my path. Not necessarily what I did last summer. I have no idea. I don't even remember. So right now in my branch, what we're doing, the primary focus is really systems. It's really a systems engineering approach. So it's a systems integration. So we're heavy into modeling and simulation of systems. So it's not the RAND's calculations. It's not as robust and detailed of models, but what it does is it takes things like fuel consumption calculators. We work with the ship evaluation tool, so it'll tell you whether the ship's going to get longer or sink when we put the equipment on. We do some reliability calculations. There's a model for that. So all these various models we put together and evaluate machinery that they plan to put on new ships. So that's what I've been doing for the last, I guess, 5 to 7 years. There really was no system approach to that. It was always develop a new component, develop a better pump, develop this, put it on the ship, see what happens. Oops, it has an adverse effect on this, we better do something else. So my whole thing is do the research, come up with a way to integrate all these models of all the components in the machinery system and evaluate what's going to happen when you put them all together on a ship. And we've been pretty successful moving down that path. So, and one of the components is, develop the models, integrate them, try to do some high-end visualization. So we also have, I know they have one here in Penn State as well. We have the CAVE system. It's a virtual environment, so you can kind of immerse yourself into the model. And then we actually have the hardware in the loop component, so we have some subscale testing that's going on. So in that bottom right-hand corner is actually it's a lift fan test for air cushion vehicle. So what we try to do is integrate modeling and simulation, the high-end visualization, virtual environment, and the hardware in a loop type testing to develop better systems. These are just some of the capabilities that we have. I'm not going to go through all these and bore you, but it's pretty much all the mechanical modeling and the techniques and software things that you would use here. I already mentioned that we do experimental testing as part of the systems engineering approach. So I talked about making it all, evaluating everything as a system, and that's really what we do. We came up with this Sequest system, which is basically can integrate all these different types of models. So we can evaluate all different types of designs and put everything together. So say in a system you need to go so fast. So you're going to need an engine with X amount of horsepower, so much generating capacity, so much cooling, et cetera, et cetera. And what we'll do is, somebody say, well, you can have a bunch of smart people sit down and say, well, if we use this, and this, these components in this combination, we can reach the end goal. And there may be a couple ways to do that the group of people come up with. And you'll do that. But what we've done is come up with a way to take all the different possibilities of combinations of the equipment and put it together and evaluate, which one can help you, meet your goal. And this is just a screenshot of how we put it together. But this is the trick of, portion of what we're doing. For instance, on this particular item, it was a generator that we were looking at. On this axis is the size, the weight, and over here is the efficiency, the kW losses. And what we wanted to do is find the lightest, most efficient, smallest generator. And so you do the analysis and you come up with, what's down here in this axis. And we're able to figure out, these ones down here actually happen to be superconducting generators. The ones that were the baseline design that the Navy wanted was up here. But that's not the end of the game. These ones are actually available, in a month. These ones down here, although they're smaller, lighter, and more efficient, aren't going to be ready for prime time to be installed on ships for another 5 years. So if you take a look at risk or time to maturity, the answer changes. And we have that built in. I can't show it right now, but there's basically a slider bar that allows you to make different decisions. And that's what I do now. So I know I went through it rather quickly, but I can think the end game is that there's machinery in Philadelphia, and we handle all the things in the guts of the ship. I got involved with it, coming right out of here, and I've been with it ever since. And it's definitely very rewarding. I guess one more final anecdote is, you go to a ball game, with your kids, or you're going to a neighborhood party and you're talking to the other people, and there's a lot of people that say, hey, my job stinks. They grumble about their job, and they're always, hey, Tim, I like my job, 80, 90% of the time. I mean, you can never like it 100%, but it really is, every day I get up and I really like going to work. And I'm not telling you that because, I'm here or Tom's paying me or any other thing. So it really is. I really do like going to work, and I really do like this type of environment. So that's it.
You can stay up here. You can stay up here. I gotta get a drink. So, I guess what we're trying to tell you, and we'll go through these in a little bit, is what you saw is you come out of school and you have some idea what you want to do, and you have some idea what you don't. But what you do is you stay, you know what your interests are, you know what you want to do, and what makes you feel good about yourself, and what lets you get up every day and go to work. And opportunities come. And I guess the one thing I will say about Carderock in general, both Philly and West Bethesda, is this: I don't think we even imagined our job even existed when we got there, or even that our jobs even existed ever. And it kind of lets you find your little niche and run with it. It's sort of 3,000 unique jobs.
Yeah, I actually created that systems approach group that I actually now run. Didn't really exist. There was a reorganization, and they put a bunch of people in a group, and they put me in charge of it and said, do something with this. So I said, oh, I want to do systems. I always wanted to take that approach, so I had latitude to do it, and so I did. And it worked out, great.
So there's two specific internship programs we're going to talk about, and then we'll, on the slides, and there's one other one we can talk about in general, in words. So the first one is the SMART internship. It's science, math, research for transformation. It's a full-on Scholarship is as it reads there. If you ask us, it's a full-on. It's you apply if you're accepted to the program. They pay for your schooling. They pay for you during the summers or the semesters you spend at one of the Navy labs. Well, it's DoD wide, so it could be any of the service. They pay for your tuition. They pay, and you get a salary. You get a fairly substantial salary while you're in school. If you're interested in that, if you're looking for scholarship money, I always thought it was a good deal. Not so much you want to be 18 years old coming to Penn State and have no idea even what you want to study and take it on for 4 years. Because if you drop out of the program because of grades or because of, and there is a GPA requirement along the way, or you do owe the government service when you're done. So if you went through 4 years of Penn State on the program, you were going to go work at Philly or Carderock or any of the other service labs for 4 years. But if you're a junior or senior and you got 1 year left and they're willing to pay you tuition plus a salary for a year, and you're going to and you have a guaranteed job when you're done, why wouldn't you? Or if you wanted to go get your master's and you're going to say, well, I can apply to the program now, they'll pay for me to go to graduate school for a year or two, and I have a job when I'm done, and my investment is I'm going to go work at Philadelphia or West Bethesda for 2 years, and then I'm going to come away with 2 years experience, salary while I was in school, plus no tuition. It seemed like, to me, a good deal.
And I think it goes graduate to a PhD.
I mean, there are some that, you could stay in the program for, 8 years, 10 years if you wanted to. You owe the government 8 to 10 years back afterwards. Thing that catches everybody on all these programs is the deadlines are early. It is, 5 p.m. Eastern time, December 1 is when the applications are due to the SMART program. There's a lot of information at smartase.org. You can go to ase.org and get all this stuff. It's under one of the pull downs. That's what you see. The other one, which is a more standard Navy Research Enterprise Intern Program, NRIP, is pretty much Navy-wide, Department of Navy lab-wide. Like I said, last year 238 college students. It is both undergrads and grads. They haven't changed. It used to be you didn't get very much money because they don't adjust it, and then they adjusted a giant amount. So it was like $5,000 and $7,000. They just bumped it up 2 years ago to $76.90 and $10.25 for the grad students. Once again, the thing that catches everybody, you're thinking it's a summer internship. I don't have to worry about it until next semester. The deadline to submit the applications is January 6th. I think the deadlines, for transcripts are due even earlier than that. No, sorry, references and transcripts are due before the actual final application. So you got to go online and start the process and get your those things done essentially in December. Those are the two official. So it's if you go to basically www.asee.org and you go under students and fellowships, they also have graduate fellowships, NSF fellowships listed there. There's another DoD one that doesn't have a. NSF and the DoD ones don't require, the graduate fellowships don't require service. You just get the money. But all of these are hugely competitive now. The little hint on both the SMART and this one is if you apply to Carderock, so West Bethesda or Philly, let us know. Because otherwise, NRIP, when it comes out, it's a list of 3,000. It is literally an Excel spreadsheet with every student who applies. And we tend to search by it for who put Philly first, who put Bethesda first, and then we don't even bother to look at everybody else because you're still looking at a couple hundred to pick out, a couple dozen. So let us know, and let us know your interest, and we'll at least try to flag them to the people that will be looking at it. The other one is there's something called STEP, which is Student Temporary Employment Program. The issue with that, it's a lot harder to come by, and maybe even harder in the future. These are SMART and NRIP are actual, SMART being a DoD program, NRIP being a Navy program. Those are funded with dollars set aside for that. STEP is essentially, you're going to Tim and saying, hey Tim, I want a summer job, is essentially it. He has to have funding in place for STEP hires.
Right. Well, the way they did it last year was they actually put an announcement out in USA Jobs for engineering interns, they called it. And you actually apply, send your resume, it tells you how to apply, and you actually apply, and then we review all the resumes. That's how they did it last year.
But I will give you, once again, if you can apply to the NRIP program, even though it's, you know, a couple hundred, if the program doesn't have funding for you and I want to hire you under the NRIP program, Tim, we can pay for you at the cost of the NRIP fellowship cost, which is substantially less. I mean, if you say, hey, Tim, you can have somebody for 10 weeks for $7,700. $7,700 is less than 2 weeks for a full-time engineer or whatever cost to us. So we would prefer you apply to the NRIP program and then say, hey, I want a summer internship at Philly or Carderock in West Bethesda, because it's much easier for us to find, you know, $10,000 to cover somebody for the summer versus
30,000.
you know, 40,000. Yeah, which is essentially what would be costing us otherwise. Anyway, questions to either one of us? If you want to know more about, like I said, how we got there, what you should be worried about, how to get a job.
For the summer internship, do any security clearance required?
They don't require security clearance per se. You have to pass a background check and you have to be a U.S. citizen for all 3 programs, for the STEPS, for the NRIPs, and for the SMART program.
I noticed that one of the programs, I think it was the engineering co-op, as far as having people rotate through different communities, maybe like 3 different divisions. But I didn't know exactly how you all actually integrate interns into the work assignments of the department.
I mean, there is after you're hired, there's an acquisition intern program which NAVC has to hire into NAVC. They do rotate through pretty much anywhere they can find rotations. So we'll see a couple come through every year. I'm sure you guys see them come through.
Yeah, we actually hire through that. You can hire through that program.
Right.
There's rotational assignments for an SEDP, Science and Engineering Development Program.
So the acquisition intern program is an actual intern program where there's a set, I think it's 2 years, 3 years?
It depends on whether it's undergrad or graduate.
Anyway, so you get hired and you do rotations. How you find the rotations is up to you and your supervisor for the home organization that that's overseeing your internship program. If you're hired into Carderock, either at both West Bethesda and Philadelphia, you'll be part of, you don't have to be, but if you're an undergraduate, you more than likely will be, or if you're a master's degree, you're probably more than likely will be. You'll be part of the SEDP program, which is Scientist Engineer Development Program, which we will have you take some coursework and you take, it's not like here, it's 2 days of something or maybe a week of something. There's like naval architecture for non-naval architects, there's technical writing, those sorts of classes. You will do rotations. You can do them through any of the departments that and specifically